Hi, today we'll be looking at decode ways. Um, but something that I feel like a lot of us do, which I have also done, is jump into problems without studying algorithms and techniques of solving problems. So it's always amazing, right, to be able to solve something on your own and getting the right answer, but that might not always be the most optimal way. In a lot of problems, it's also seen that there is no other way than the optimal way of solving it, and that requires knowledge of a certain algorithm that you must be studying. It's just like, studying before exams. So I feel like this problem, decode ways, I couldn't have done this unless I had studied the concept of front partition, um, which is a dynamic programming concept. And before that, you need to know recursion, you need to know why we want to use recursion before even we use it, like why. So let's just go through this. So um, message contains letters from A to Z that can be encoded into numbers using the following mapping. A stands for 1, B maps to 2, and Z maps to 26. To decode an encoded message, all the digits must be grouped and then mapped back into letters using the reverse of the mapping above. There may be multiple ways. For example, 11106 can be mapped into AAJF with the grouping 11106 and also KJF with this grouping. Note that the grouping 111 and 06 is invalid because 06 cannot be mapped into F since 6 is different from 06. This is a very important edge case which you should be thinking about even if they haven't mentioned it, right? In a real interview, given a string S containing only digits, return the number of ways to decode it. Yeah, so that's it. This is all great. Now, when you look at this, let's say you are at this index, you can either just take this index, you can also take like the next index, you can also like create a thing by taking the next three indexes, next four indexes. So you need to try out all ways. And when you need to try out all ways, what comes into your mind is recursion. You need to try out every single way recursively and then arrive at the answer. So once you are here, right, like let's say you took two, you need to try out with one, and then again you need to try out with 10 and then 106. That's how you need to go. So it's important to try out every single way, hence recursion. So first, um, we'll go ahead and write the recursive code. Now, I read about front partition in Striver's DP series where you have this like it's very intuitive, right? You have just forget this DP part for now. You are at an index. You need to know what you can do at this index. So from this index, um, you start from this index, go to the next, and in this, you need to try out all combinations. So from the starting index, which is I that we started with, till this index, end index, which is moving, you first try with 0, then you try with 1, 2, 3, 4, and so on, lengths. So that way you try out 1, you try out 1, 1, you try out 1, 1, 1, and then the rest is another subproblem. So what this f of I signifies is how many um, number of ways are there to decode just like let's say if it is at index 2 in this string, then how many ways are there to decode the string 106? That is what this f of I signifies at this index. So at every index, you start from that index, you keep on moving through that index, and you try to see if, at each partition, the number of digits or like the left partition is valid or not. If it is valid, then try to recursively check all the other combinations of the right half of the partition. So this is what we do. So first, if the left part is valid, only then check if it was check for the right half. That's it. And what are the base cases? Where do you stop this recursion? So if you reach the end of the array, that means you reach the complete end. That means that this is a valid, set of partitions and this exists. So this is correct. Now, if you're at the second last index, then you need to see if this one is valid or not. If it is, then return one, and else return zero. I just want to try out one thing. I want to just try commenting this part out and see if it runs. Feel like I've added more code where it was not required. Yep, it solves it. So we don't need this part of the code. That was just redundant code that I had written. Yeah, it's important to be able to identify these things. You don't need that edge case, right? I did not need that edge case. It's just that if it reaches the end, it returns a 1. So when you have this count problems, right, it's either you return a 1 or a 0. So that's what. So here you just return a 1 or a 0 here. And if let's say you were never able to reach n, then you don't need to return anything. So that's that. So it counts. And now once that you have solved this, you'll have this time limit exceeded issue. Now, what happens when you have a time limit exceeded, right? So you have this index. Let's look at this one, right? So here we are. Consider this one. So if you take this one as a single one, the first index as a single letter and the second one as a single letter, or you take these two as one single letter, you're still going to come to this 106 part of the string where you need to find out from this index what are the number of ways to decode it. So this part of it remains the same and you have to do it multiple times. So we have overlapping subproblems, and this is where you can use dynamic programming, basically memoization. So need you can store like this array which calculates like if you calculated this somewhere previously, you just store it, and the next time you see it, you don't need to recalculate it again, you just use it from this array, and that saves you a lot of time and gives you the optimal answer. So that's it. Thanks for watching.